So yesterday we talked about, we introduced the idea of periodic functions, and we looked at, a few different things that we could do with them, but I tried to uh, make it clear that the properties of periodic functions were kind of going to be the most important ideas that we're going to need for this unit moving forward. Okay, and we're going to see a lot of that today. We're really going to talk about those particular properties that we introduced yesterday. And that is because we are talking about two very specific and very important periodic functions. And these are the two functions that really the entire rest of the unit is going to be about. And those properties that we introduced yesterday are going to be a main part of how we are going to work with these functions. Um, but then we looked at those other sort of general things that have to do with periodic functions as well, the function notation stuff, that sort of thing. Okay. But now we're going to focus on these two, and they are the graphs of sine and cosine. Now, we have thought of sine and cosine and tangent as the ratios that are used for triangle trigonometry. Well, turns out that that there's a lot more to them than we know, and we're just going to see a little bit of that, okay? And so what we're looking at is, what if I graphed the function y equals sine of x. This is kind of like, what if I graphed y equals 2x? So I take x and I multiply it by 2. If x is 5, then y would be 10, right? You got an input and you got an output. Well, I can do that with any kind of operation, and sine is an operation. I mean, I can just punch a value into sine and see what I get, right? Sine of 30 is a half. So what I'm looking at here is, for this one, x is given some value. I take the sine of that value, and that becomes my y. And that's how we're going to graph this. Okay, and we're going to graph sine, we're going to graph cosine, and we're going to notice that they're periodic. No surprise there, because that's what we've been talking about. And we're going to start to look at their properties and that sort of thing. And then we're going to do all kinds of other stuff with equations and that sort of thing later on. But for now, we're just going to focus on graphing them. And the whole point over the next several days where we're doing this is for us to get used to what these functions are like, okay, what their properties are like, and different things about their equations and how that changes what they look like. And we already saw yesterday the example of the Ferris wheel, how these can represent real world situations. And so, this is eventually kind of going towards that. To do this, we are going to need our calculator. So go ahead and pull up your calculator. And one thing that I want to point out when we're working with our calculator, okay, for my calculator, I have these DRG. Sometimes it's a DEG and then RAD and then GRA probably, or GRAD. So sometimes it's 3 letters and it cycles through them. On this calculator, it's either a D, an R, or a G. On the computer calculator that I use, it doesn't show that. It just shows all of the stuff, unfortunately, at the top all the time, okay? But for example, if I wasn't in degrees, so let me see if I can fix that. Okay, so mode, nope, that was wrong, sorry, shift mode for setup, and I'm gonna change it into radians. And if I did and if I'm in the wrong mode and I do sine of 30, I get the wrong answer. Okay, I get some answer that doesn't make any sense for what we're talking about. So I'm going back into my setup. I'm hitting number 3 to put it in degrees. Every calculator is different. You're going to have to figure out how to put yours in degrees. And then when I do the sine of 30, I get the answer that I want, which is a half. Today we're actually going to use decimals, so I would hit the SD button on this calculator to change it to a decimal, or figure out what the decimal is of that fraction if it's a funky fraction. And the decimal answer is one we're going to want. So take your calculator, Try to do the sine of 30. Remember, some you put the 30 in first, then you hit sine, but not on this calculator. That won't work. Make sure that when you take the sine of 30, you get a half, and that's the way you know you're in the right mode. Or you can look at the top of your calculator, and it probably has a D or a DEG, and that tells you you're in degrees. The last thing I'll say about this is if you can't figure out how to put your calculator in degrees, it's not in degrees. It's almost always the default, so try to look for the reset button on the back, reset it, and that'll probably put it into degrees, okay? Look it up on the internet if you have to, whatever you have to do, make sure you're in degrees. So here's what we're gonna do. We are going to fill out this table of values, and then we're gonna graph those and see what they get us. So sine of 0, do the sine of 0. On your calculator, what do you get? You get 0, okay? Do the sine of 30. We just did that one. What do you get? A half, but I want the decimal, 0.5. Sine of 60. Okay, you should be doing these too. I'm not going to do all of them. So this gives me a strange fraction with a square root sign in it, root 3 over 2, but I don't want that, so I'm going to hit this button. I'm going to round it to 2 decimal places. For this graphing, I'm not going to be able to tell the difference between 2 decimal places and 1 decimal place, but I'm going to include 2 because it looks nicer in my table of values. Okay, keep going, do the rest. Sine of 90, and complete the rest of them on your own. Okay, and when that's done, we'll come back and we'll figure out what to do next with it. And bam, there's all my answers already done. And you can pause and do them yourself, or you can just look at mine and copy them down. As long as you know how to punch it into the calculator, you don't really have to go through that exercise yourself. So I've got them all down for sine. I've got them all for cosine as well. We're going to do those ones later. And what do you notice about these? Take a look at that list. There's something that should jump out at us. What do you think it is? There's a lot of repetition, isn't there? So I've got 0.5 happening over and over again. In fact, it goes 0 to 0.5, 0.87, 1, back to 0.87, back to 0.5, back to 0. Then it repeats, but just in the negatives. So negative 0.5, negative 0.87, negative 1, negative 0.87, negative 0.5, 0. So we've got this repetition. Well, I hope that's no surprise because we know periodic functions have this repetition in them. And we already know this is a periodic function. We're not being coy about that or anything. That's why we talked about what periodic functions were yesterday, because it's going to be important. So now what I'm going to do is I am going to go ahead and I'm going to plot these points, and we're going to see what this curve looks like. So 0, 0. Notice that I go 3 squares to get to 90. That means I'm counting by 30. 30, 60, 90. 120, 150, 180. Okay, so we're not counting by ones or twos or fives like we often would, and that does make it a little bit trickier that this scale is sometimes going to count by something strange. Okay, so that's one of the things that we're going to want to get used to. So the next one is 30 and 0.5. That means I'm going over 30 and up 0.5. Again, looking at the Y scale and seeing that it's counting by 0.5s, 0.51, 1.52, and so on. Okay, 60, so that's going to be here, and 0.87 is going to be more than halfway up to the top there. You don't have to be perfect. And then 90 and 1, and then 120 and 0.87. So I'm making that sort of flush with the other one, right? Because those are the same, so they're about at the same spot. 150 and 0.5, and 180 goes back to 0. Continuing on, I'm here, I'm here, I'm here, here, here. And if I can see that pattern of repetition in these values, then it makes it a little bit faster to plot those points. Okay. Now we just connect those points and we get our curve. And there you go. And that is the graph of y equals sine of x. That's what it looks like. And in fact, if you graph this on a graphing calculator with technology or something like that, that's what it would look like. Now, all we've done is from 0 to 360. So I will just tell you that's one cycle. So after that, it's going to continue on and on and on like that, okay? And same thing this direction. Whoops. This direction, it's going to continue going that way as well. It doesn't stop. We often, when we're graphing, we only graph one cycle, but it is periodic, so it does go on forever in both directions. And that's something that we want to remind ourselves of fairly often, because we're going to forget and we're going to think that sine just looks like the one cycle, but it actually goes on forever and ever, okay? In both directions. We'll see a little bit of that when we use some technology a little later. So that is sine. That's what it looks like. Remember, properties of these things are what are important about them. It's how we can talk about how it's changing, or that it represents a Ferris wheel that's tall or that's short or that's fast or that's slow, that sort of thing, okay? So we want to write out some of those important properties, and then we're going to use them to talk about, under certain circumstances, when those properties change and how that changes the graph. So this graph has a max value of 1, okay, max, and a min value of -1. So that's a total distance of 2, and the amplitude is half of that. So the amplitude of this is 1, okay? And remember, the amplitude is half the distance between the max and the min, and it's 2, 1, 2, so half of that is 1, or it's the distance from the middle to the top and the middle to the bottom. And I can see that the middle is this line here, and the distance to the top is 1, and the distance to the bottom is 1 as well, right? So the amplitude is 1. The max is +1. The minimum is -1. And the period is 360 degrees. That is the length, or the distance that one cycle occurs before it starts to repeat the pattern. So I went up and back to 0, but I'm not repeating yet, because that would look like that if I repeated again. So I'm going up, then I'm going down, and that's where it starts to repeat, okay? So it starts to repeat at 360, so I have a period of 360 degrees. That's the length of one cycle. Now, we are going to transform this graph. Remember, doing transformations of quadratics. We're going to do transformations of these trig graphs. So this is for the standard base graph, okay? Without any transformations, the period is 360. That can be changed, and we'll take a look at that a little later. But for now, it is 360, and that's the standard period. Just like the amplitude, the standard amplitude is 1. That can change. The max and the min, those are the standards. That can change, okay? Last thing I want to talk about, it's not one of the properties that we talked about before, but it's going to be important for what we do, and it's called the zero line, okay? And it is the middle. So the zero line of this one is y equals 0. We usually, here, I'm going to do it like this. We usually write it that way as an equation, y equals something. It's always a horizontal line. And it is where the middle of the graph vertically is. So this line where I go up, where I start from that line and I go up to the max, and I go down from that middle line to the min, okay? That line is going to have a special name for us, and that's going to help us graph. We call it the zero line, and for the parent function, it is y equals 0. Last thing I want to talk about is we focus on 5, here I'm going to do it in a different color, 5 key or important points. Okay, for both, we're going to do 2 different graphs, sine and cosine, and we're going to focus on 5 key points. We're not going to plot all these points, right? We're not going to plot every point that we see here. We're going to plot this one, which is the first, this one at the maximum, this one that goes back to that middle line, this one at the minimum, and this one where it ends. So there's your 5 points for sine, that every time you graph sine, you need to have those 5 points in the right places. We don't do any of the other points that are in the middle. We don't graph those, okay? We just get the 5 points. They're the easiest ones to find, and then we draw a smooth curve through them. So that is what sine looks like, okay? Here's cosine. So you could take a minute and do these values on your own with your calculator, or you can just copy my values. Again, notice there's a lot of similarity. Those are all the same values that we saw before, okay? But they're not the same as, they're not in the same places as sine, because sine of 0 is 0, where cosine of 0 is 1, right? So they're not the same, but I had a 0.87 for sine, and I have 0.87 for cos, 0.5 for sine, 0.5 for cos, that kind of thing. So at 0, cosine is at 1. Then it goes to 0.87, then 0.5. At 90, I'm at 0. Then I'm at negative 0.5, negative 0.87, negative 1 at 180, negative 0.87, negative 0.5, 0, 0.5, 0.87, 1. And that's where it starts. That's where cosine starts to repeat. Okay, and then I'm going to connect them with a smooth curve. Try not to make it look like a V. It doesn't go like that. Okay, it's curved as much as possible. Try not to do these, what I call hairy lines, where you're kind of coloring it in as you go. Okay, try to avoid that as best as you can. And that is cosine. And again, it continues. Whoops, that wasn't very good. Okay, like that. And continues this way as well. But we, again, just draw one cycle, and there is one cycle. Again, take a look at my properties. It has an amplitude of 1. Okay, because it has a 0 line in the same place, and you go up 1 to get to the max, and you go down 1 to get to the min. It has a max of 1 and a min of negative 1. It has a 0 line of y equals 0, just like sine does, and it has a period of 360. So the properties are all the same, but what's different is the key, those 5 key points, because sine starts in the middle, then goes to the top, okay, and then continues. Cosine starts at the top, goes to the middle, goes to the bottom, the minimum, back to the middle, and finishes at the top. That is the most important difference between sine and cosine when we're looking at the graphs. Basically just where it starts. The rest of the properties are basically the same. So there's your 5 key points for cosine. Now, I am going to talk about the equation a little bit here, and this is where we're going to go for the rest of this lesson. Okay, and here's what the equation of sine might look like. Y equals a bracket sine bracket again. Maybe I'll do a square bracket actually. X minus c plus d. Okay, or y equals a cos x minus c plus d. Now, there is going to be some technology that we're going to use in for today to try to understand this stuff. Okay, we're going to use some technology. So there's 2 links to 2 different little activities on your computer that are going to help with this graphing stuff, okay? And the first one, you'll find these in the Google Classroom. The first one, I'll show them at the end of this video. The first one is Desmos, okay? And that's an activity that if you want, you could go and do now. And what it's going to do is it's going to help you explore what these variables mean, okay? And if you were good at graphing quadratics, you might be able to guess what they mean. But if you want to try to explore it yourself, some people like kind of figuring things out themselves and it helps them remember stuff better. So if you think that's the case, you can go and fiddle with the Desmos thing now, pause the video, go fiddle with it and come back, okay? Or you could wait for the next thing that I'm about to do where I'm going to show you something and I'm going to talk about these three things, A, C, and D. And you could watch me do that. Then you could go do the Desmos, and then you already have a bit of advanced knowledge on what is happening. You don't have to figure it out for yourself, but it might help you connect to it a little bit better if you get to play around with it on your own. Or your other choice is watch the whole rest of the video, and then go and do the Desmos activity at the end. So it's really up to you. If you do it now, if you pause right now and do it, then you get to kind of discover it yourself. If you don't, then whether you do it sort of after I show you what I'm about to show you or at the very end of the video probably doesn't matter much. But I do encourage you to do it one way or another, okay? So that I think that's really important, is going to the Desmos activity and completing it before you move on and do any paper practice, okay? And I'll talk about the other technology activity that I have at the end of the lesson, okay? So if you want to try to figure it out yourself, pause now. Otherwise, I'm going to talk about the A, the C, and the D with a bit of a different demonstration using Geogebra. Okay, this is Amplitude is just for me. It's not one that you'll be able to find. So, but what it does is here's sine, and take a look at how it has the 5 key points. It's actually got the same scale, counting by 30s horizontally and counting by 0.5s vertically. So it's the exact same scale as the ones that we saw. And take a look at sine, how it starts at 0, at 90 it's at the max, and in this applet at 90 it's at the max again. So you can see that these are the same graph, okay? So what am I going to do? Well, A is 1, okay? Because this is just a graph of y equals sine of x, and that's y equals 1 times the sine of x, right? That's what that means. There's a 1 out front of here, just like x means 1x. So what's going to happen when I start dragging the 1 and I change the value? Watch what happens, okay? It's changing the equation. So it changed it to a 1.5, whoops, then to a 2 in front of the equation. So this is now the graph of y equals 2 times the sine of x, 2 sine x. What did it change? Okay, it's making it taller or shorter. But when we're talking about the properties of the function, what is it changing? So it's changing the max and the min. But even more importantly, it is changing the amplitude. Okay, so the A is a change in amplitude. Okay, the A is the change in amplitude. And if I make it negative, look what happens. It's a reflection. And that is the same as quadratics. If I have a negative out front, y equals negative x squared, that's a reflection in the x-axis, and it's the same for sine. Okay, so I've reflected it, and now I'm making the amplitude bigger, or I don't reflect it, and I'm making the amplitude bigger as well if I drag A and make it bigger, right? If I start with it at 1 and I drag it smaller, I'm making the amplitude smaller. Okay, and you can think of it like this, those 5 key points. Typically speaking, sine starts at 0 and goes up to the max. But if I flip it, it starts at 0, and instead of going to the max, it goes to the min, right? Then it goes back to 0, then it goes to the max, then it goes back to 0. So you think about where it's starting and where it's going at each stage for each of those 5 points. And that's how we're going to graph these functions, okay? Okay, what's next? We're skipping K for now. We'll come back to that in a little bit, not today, in a few days. Let's take a look at D. I think it's the next sort of easier one. So D, what do you think it's going to do? D is this number added out here. Right now it's 0. Whoops. Right now D is 0. Okay, so it's sine x plus 0. And what happens when I drag it up? It doesn't change the shape of the graph, it just moves it all up. And again, that's very similar to quadratics, where the D on the outside of that's added at the end just moves it up, or if I subtract, I'm just moving it down. But take a look at how I don't change the shape of the graph. I'm not changing the amplitude, I'm just changing the uh, the position vertically of the graph. Okay, and then so let's write that down. This is a vertical shift. Okay, and finally C is your horizontal shift, just like it is with quadratics. So what it's changing, again, it's not changing the shape of the graph, but look, it's changing where that first point is. Instead of being at 0 like it was before, now it's at 90. Okay, so that's what it's changing when I drag C back and forth. And notice that when I subtract 90, I'm moving to the right to positive 90. And when I add 60, let's say, I've moved to negative 60. So it has the opposite effect, again, just like quadratics. Okay, so we've already seen this with quadratics. We've seen vertical stretches. Now we're calling that a change in amplitude. We've seen horizontal shifts and we've seen vertical shifts. Okay. Last thing I want to talk about is people think, a lot of people make mistakes, okay, when they're learning this, because the amplitude, I just changed the amplitude to 2, right? Because now I'm going from the 0 line up 2 to the max and the 0 line down 2 to the min, okay? And so people will think, for example, if I drag D up here, people will think the amplitude is 3 because that's where the max is, right? People will think the amplitude is 3, but it's not, because the amplitude is the distance from the 0 line to the top and the 0 line to the bottom. And if let me reset all of this. My amplitude is 1. There's my 0 line, that red dotted line, up to 1, down to negative 1. If I make the amplitude bigger, now it's up 2 and down negative 2, up 3 and down negative 3, okay? But if I drag this down, I haven't changed the amplitude because I've moved the 0 line. And then if I drag, now if I change the amplitude, now that's a distance of 2, okay? From the 0 line up to the max, I went up 2, but my max is actually at 1. So the max value is not necessarily equal to the amplitude, okay? Because if I move the 0 line, then I'm also changing where the max and the min are. So my amplitude has to be the distance from the 0 line up and the 0 line down. It's not just the max or the min of uh, the function, okay? So that's how we're going to practice. That's how we're going to do it, but you have to keep that in mind, and it's a common misconception. It's a common mistake in our thinking that we get used to this pattern that that uh, I can just look at the max and the min for the amplitude, okay? That won't actually work. Okay, so that's the demo. That's what the A, the C, and the D do. If you want now, you can go and try, if you didn't do it already, the Desmos activity because that's what it will talk about, and it will have you moving some graphs around based on the A, the C, and the D, and just playing with that. And it's a bit easier than doing it from scratch on paper, doing it with the Desmos activity. So I would recommend you do that first before you try to do any of the examples by hand. That being said, if you wait till the very end of the lesson to do it, that's okay too. What we are going to do next is we're going to do a couple of graphs um, where we take into account the transformations in the graphs, and we're going to graph them with the transformations in the space provided. And we're just going to do 3 of these. So we've got 2 sines and a cosine, okay? And then then you can do the Desmos activity if you haven't done it yet, and I'll show you the other activity involving technology that you can try. Okay. So we are going to use a method for graphing that we at Galt Collegiate like to call the 5 key questions. Okay, but we're not gonna use all 5 yet. So I'm not gonna talk any more about the 5 key questions. We're only gonna use the first couple today. Okay, so I'm not gonna talk about them in terms of the 5 key questions, but I just wanted to mention it because by the end of all of this, there will be 5 questions that you'll answer. And what we're going to do is we're going to use the equation to answer those questions. And what those questions do is they just walk us through figuring out the properties of this function with its transformations so I can turn it into a graph. Okay. And so we're going to see with the work that we do today, we're going to see how a couple of the questions give us those properties that we need. But we're not doing all the transformations yet today. We're only doing a couple of them. So that's why we don't need to do all 5 questions, okay? For today, we start by writing out the amplitude and the 0 line, and then using those 2 things to find the max and the min. Okay, and then once we have that, the amplitude, the 0 line, and the max and the min, then we have to think if we're graphing sine or cosine and what those 5 key points are. Okay, the 5 key questions and the 5 points are 2 different things. A bit confusing because we call them, there's 5 of each of them, I suppose. But we'll think about the 5 points, the 5 for sine and the 5 for cosine, and where they are based on that information that we're going to write out. Okay. All right, let's start with the first one. So the base graph is y equals sine of x. The graph we're doing now is y equals sine of x plus 1. If you remember, what is that? That's a d value, and that's a vertical shift. Whoops, I forgot to write this down, so I'm going to write this down now, horizontal. Sorry about that. Let's get that out of the way before we move on. Horizontal shift. Okay. Okay, so this is a d value. It is a vertical shift, and we need to know that. Okay. Something that can be really useful before we start doing what will be known as the 5 key questions later is write out the values of A, C, and D. So A didn't change. A goes out in front like that, so it's just 1. C didn't change because it would look like this. Y equals A sine x minus C plus D. So there is nothing added to the x because it's not in brackets like that. So C is 0 and D is 1. This is the D value in this case. Okay, this is a really good idea, especially when you're starting, is write out the values of those variables based on the equation that you're looking at. Okay, we're starting with that. Now, what I always start with is I write out the 0 line. And the 0 line, again, if we look at this, let me reset it and get rid of actually, I'll put the 0 line in there. It's that red line is impacted by the shift. I can change the amplitude as much as I want, and I can change the horizontal shift as much as I want. Whoops. Okay. But it is only the d value that moves the zero line. So the zero line comes from the d value, and it is y equals 1. As you practice this and get used to it, you'll start to remember this. I think I think doing the Desmos activity or playing with this kind of an applet helps us visualize and understand and connect to that idea. But ultimately, it's something that you just have to remember. You have to remember that the y value, that the zero line comes from the d value. Okay, you just do need to know that. So d was equal to 1, and that's how I got y equals 1. The amplitude. The amplitude for the base function is 1, right? We wrote that down up here. For the base function, it's 1. And what changes, which one of these letters changes the amplitude? Well, C doesn't. D doesn't. D changes the max and the min, but it's not changing the distance between the zero line and the max. So that's A. A changes the amplitude. And A is just 1. That's the normal one. So the amplitude hasn't changed. So the amplitude is 1. Okay? And this comes from the A value. And again, that's something that you just need to get used to and remember. From this, we write out the max and the min. And again, I'm going to use this applet to think about that. My D value is 1, and that moves my zero line up to 1. Okay? That means my max, the maximum is the zero line up the amplitude, and the minimum is the zero line down the amplitude, right? That's the relationship between the amplitude and the max and the min. Is the zero line is the middle, and I go up the amplitude to the max and down the amplitude to the min. That's just the way that it works. So that means the max is going to be the zero line, which is 1, plus the amplitude, which is 1. So the max is going to be 2. And the min is going to be the zero line 1 minus the amplitude 1, which is 0. And again, we can see that here that I've gone up to put my zero line at 1, and I go up the amplitude to 2 and down the amplitude to 0. A bit of a tricky example because it's all ones, but if you followed it with the video, hopefully you saw where each one came from. Now, I usually write it like this: max and min, just to speed it up, is 2 and 0. Doesn't really matter the order. You could write it min, then max, 0, 2, doesn't matter, as long as you know what that means. Okay? So for this question, that's all we need to do. We've actually only answered 2 of the 5 key questions, but again, we'll talk more about that once we put them all together, okay? So the first step here, as I said, is write out the zero line and the amplitude, and then use those to come up with the max and the min, okay? Now I need to go back and think about what the sine function looks like. And sine always starts in the middle, which we now know is the zero line. So it starts on the zero line, it goes to the max, back to the zero line, then to the minimum, then back to the zero line. Now, if it's flipped, it doesn't go to the max first, it goes to the minimum, but this one's not flipped, so it's going to follow that same pattern. So you might want to draw in your zero line. That would be fine to do that, okay? So my zero line is y equals 1. I'll do it in a different color. And sine starts on the zero line. And it starts at 0 unless it has a horizontal shift, but we're not doing those today either. Then it goes to the maximum. Now, this is one thing I haven't talked about, okay? The period is 360. Because I'm counting by 30s, 30, 60, 90. That means one cycle is going to be 12 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, it's going to be 12 squares, and 12 divided by 4, 1, 2, 3, 4, because I can divide it into 4 quarters, is 3 squares each. Okay, so my period of 360 is 12 squares in with this scale that I have. And between each of the 5 key points is 3 squares. Now, it seems strange at first to talk about how many squares, but you're going to realize later that counting squares and thinking about how many squares is going to be really important, okay? So I got to go to 90 to get to the maximum. And if I'm counting by 30s, that's 3 squares. And again, that just comes from this, that the maximum happens at 90, okay, of the base graph. And I haven't changed that with any of these properties. So I'm counting over 3 squares to 90, because this is the same scale, and I'm going up to the maximum. 3 squares, 3 more squares, back to the 0 line. 3 more squares to the minimum. How do I know what the max and the min are? Remember, we just calculated that. And if this seems strange, how do I know? Okay, well, I'm going to finish this. 3 more squares back to the 0 line. How do I know that this is on the 0 line and this is on the 0 line? Because that's what sine does. And when you're seeing it for the first time and it's not as obvious, it's maybe hard to follow, but this is just what sine does. That's what it looks like. And after you've practiced it, you'll get it. Just like after practicing quadratics, you understood what they look like, okay? So now I have graphed my 5 key points. Notice that they're very similar to this graph. Okay, I started at the 0 line, then I went to the max, then I went back to the 0 line, then I went to the min, and so on, right? And I did the same thing here. And so now I'm going to connect those points with this, whoops, that wasn't very good, with a smooth curve. Whoa. Okay, and there's my sine curve. It's got 5 points. Sine always starts on the 0 line. Unless it's flipped, then it goes to the max, back to the 0 line, to the min, back to the 0 line. And if you do the practice, you will just start to remember that that's what sine does. Okay, let's try to get the last 2 done here. I hope that that's clear. I hope you get that. Again, like lots of things, it might seem strange at first, but as you practice, hopefully it will get better, and you'll start to make the connections and start to remember these things. So again, I'm going to do the same thing. Y equals a cos x minus c plus d. So what is a? What is c? What is d? Well, look, a is 2. That's what it looks like to have an a value. C is still 0, and this time d is also 0. Okay, so there's my a, c, and d. That means my 0 line is y equals 0, because it's just the d value. It's always y equals the d value. What's the amplitude? It's 2. It's the a value. Okay. By the way, I'll talk about that in the next example, actually. Okay, now I use the 0 line and the amplitude to figure out what the max is. My 0 line is y equals 0. I go up 2 to the max, and I go, whoops, down 2 to the min. So my max and my min, so the max is my 0 line plus 2, which is 2, and my min is my 0 line minus 2, which is negative 2. My max and my min are 2 and negative 2. Okay, you don't have to write it twice. I'm writing it this way to show how I'm getting it. This is, as I said before, usually how I write it. Okay, again, let's put in our 0 line. It didn't move this time, so it's just on the x-axis. Now, I'm starting again at 0. I don't have a horizontal shift either. Oh, sorry, I don't do that. It's cosine. My mistake. This one is cosine. Cosine doesn't start on the 0 line. Where does cosine start? You may have to look back at this graph of cosine to remember these things while you're practicing, and that's fine, right? You got to remember where the 5 key points are. So cosine starts at the max, goes to the 0 line, goes to the minimum, goes back to the 0 line, and goes back to the max. Okay? So cosine starts at the max is 2. Then in 3 squares at 90 goes to the 0 line. 3 more squares goes to the minimum. 3 more squares back to the 0 line. 3 more squares back to the maximum. Again, if you're wondering why 3 squares, well, take a look. That's what gets me to 360, which is the period. We're not changing the period. It's still 360. And there has to be an equal number of squares, an equal distance between each of those 5 key points. That's how both of these graphs work. Okay, so for now, it's always going to be 3 squares. This is cosine. Oops. There we go. Again, try to make it curved. Don't make it go like that and be straight or anything like that. Try to make it at least somewhat of a smooth curve graph. Notice that the amplitude is 2 because I stretched it, but I didn't move the 0 line. One last one here to do, okay? And a couple things to notice. Let's do this one bit at a time. Y equals A sine x minus C plus D. So A is negative a half. C is 0 again, and C will always be 0 today. We're going to look at that tomorrow, even though we talked about what it does today, and D is negative 1, okay? But tomorrow we're going to actually see what happens when we change C and practice graphing that. So today all we're changing is A and D. Let's start with the 0 line. It's y equals negative 1. And if you want, you can go ahead and add that in right away. Of course, it's up to you. Okay. Now the amplitude, this one's a little bit different. The amplitude is not negative a half, it's a half. Because amplitude is always positive. Okay, it's a distance, not a direction, because the amplitude goes up and down. So it's always positive. But the negative tells me that I have a reflection. Okay, so the max, now I calculate the max and the min. Notice I've done the same steps every single time. Start with the 0 line. I just say what it is from the D value. Then I state the amplitude from the A value. Then I come up with the max, which is the 0 line plus the amplitude. And then the min, which is the 0 line minus the amplitude. And you probably want to use decimals for that, not fractions, right? It's easier. And so the max and the min are negative 0.5 and negative 1.5. Okay? And this is sine again. Sine starts at the 0 line, so I can put my first point there. But this is usually sine starts on the 0 line and goes to the max, which would be here. But we have a reflection. So instead of starting at the 0 line and going to the max, I start at the 0 line and I go to the min. Again, 3 squares. Back to the 0 line, 3 more squares, 3 more squares. Now I'm at the max, 3 more squares, back to the 0 line, because that's what sine does. Starts on the 0 line, ends on the 0 line. Nice. And notice how it looks a lot like sine, but it's reflected. Okay, let's take a look at this. I moved the zero line down, I reflected it, and I changed the amplitude to be smaller than it was because it's a half. Negative 0.5 sine of x minus 1. Negative 0.5 or half sine of x minus 1. Same thing. So that is graphing trig functions with a couple of transformations. I know it seems strange at first, but you have to focus on these properties. That's why we talked about these properties yesterday. The zero line and the amplitude, the middle, the max, the min, all of these things, right? And if you can focus on those and try to see the relationship between the zero line and the amplitude and how it gives us the max and the min, that's how we find those 5 points. And that together with just knowing that sine looks like this and cosine looks like this, like you have to just know that, right? You're not figuring that out as you go. So eventually, not for now, you can just use your notes, but eventually you remember that cosine starts at the maximum, sine starts at the zero line, and so on. All those 5 points that I've talked about lots, we'll just remember that. We'll just know that. Okay. And that's it. I am going to talk about the two activities. So I'm going to show you the Desmos one quickly to make sure you understand it. And then I'm going to show you the other activity. The other activity is Geogebra. They're both linked in the classroom. And the Geogebra one is, we've seen this before, it's actually an applet where you can do exactly what we're doing right here, where it'll allow you to graph a bunch of these, okay? So, like I said, I'm gonna show it to you and show you how it works. I would recommend doing that before trying to do some of these by hand. So there's going to be some work for you to do these by hand as well, but you could use the Geogebra applet and do the Desmos first to get used to the A and the D value in particular and how they change and how it puts those points. And the great thing about the Geogebra applet is it's going to tell you if you're right or if you're wrong. Okay, because graphing can be hard. Even if you have the answers that you can look at, the solutions, you might think your graph looks like the graph from the solutions, but if it's not exactly the same, it's not good enough. So when you're doing the Geogebra applet, I'll talk about this more when I show you, when you do the Geogebra applet, if your point is off by even a little bit, then that's wrong, right? That's a mistake that you have to try to figure out. And then eventually, you want to be able to do it on paper by hand as well. That's what we're working towards. We're going to do this over a few days. We're going to add a little bit to it each day, but we're going to have some time to get used to this. Okay, so like I said, there are two links in the classroom to these two activities, and the first link should take you to a screen that looks like this, obviously, except it probably won't say welcome back, Brett. It'll say something else. If you're not signed in, it won't know who you are. But anyway, it'll have everything else. It should say Trig. It won't say any recent activities here. Sorry, that's just my stuff. But it should have enter your class code, and that should be filled in. And when you hit join, you should see this page right here. Welcome to trigonometric graphs. Okay, continue the activity, your name or not. You it's a good idea to sign in. Use your Google School account to sign in because then it will remember who you are if you have to take a break and come back to it. It'll remember where you're at, that kind of thing. So that's a good idea. Please use your name because I can see your work. So even if you're not signing in, if you're just typing in your name, use your actual name, and then I can follow what you've done, that kind of thing. Okay. So you can read through the instructions. I'm just going to walk you through it quickly. Next, the first one is some of them give you sliders and some of them you have to enter values. And all you're going to do is drag the slider until the blue line is on the red dotted line. And what you're thinking about is how changing the d value is the d in the equation, just like we saw in the lesson. Okay. If you're watching this part of the video, you've watched the rest of the lesson, so the cat is out of the bag in terms of what the A, the C, and the D do. If you already did this on your own to discover, that's fantastic, and hopefully you figured out that the number at the end of the equation here moves it up or down but doesn't change the shape. Okay, so this d value is the same d value in the equation, and we saw what graphing a full equation looks like. Okay, so you just drag it around until you get there, but think about the value. Don't just ignore what's happening on the left here. You got to think about the equation. That's the whole point. You're thinking about how changing the d value affects the properties. Okay, so you're going to do that a few times. There's a change in c and d, so you got to change two things, and again you got to try to match the graph, and eventually you're going to get to a point where you have to change the values yourself. So all you're going to do is select the value, and you can change it from minus to plus, and you're going to type in whatever value you want it to be. Okay, and so this forces you a little bit more to think about what the value actually has to be and look at the key points on the graph, as opposed to just dragging sliders like, I could teach my 6-year-old daughter to do that because she wouldn't have any meaning what it is. She would just drag the sliders around until it matches. Okay, our main focus is to think about these numbers and how how changing them in the equation changes the properties of the graph. So I want this blue one to look like the red one, and you can see there's a whole bunch of them. It goes up to 20. So there's a whole bunch of different ones that you can try. Good practice to think about matching them. So that's one of the activities. This can be kind of a discovery activity, as I said, which is nice because sometimes when people figure it out on their own, they remember it better. But it's a simple way to introduce us to the idea of trig equations. That's one of them. The other one, if you've watched the whole video and hopefully you are at least kind of understanding what I'm talking about with these 5 key points, that kind of thing, before you start graphing with paper, this is a really good activity that you can do to graph with technology, and it's going to check your answers and make sure that they are correct. Okay, so we have done this before, but if you haven't done it, I'll run you through the instructions of how to use this. If I click new, it's going to give me a new function. I'm going to do this function first, so I'm not going to click new yet. I will later. If I click place point, I can place points. Okay, it's going to snap to the grid, which is useful for us. I can clear all those points if I want to. If I'm placing points and for some reason I want to drag the grid, I have to click this button, move grid, and that should allow me to drag the grid around in case I need to put a point over here or way up here or something like that. Again, I can clear the points, click place point again, and start clicking to put points. Okay. If it totally gets messed up with Geogebra, you can always click this little button here and it will just restart it from scratch the way that it was when you first loaded it up. Okay, and in fact, if I click new a whole bunch of times, I guess maybe I'll go ahead and do that. Whoops, that's not good. It'll bring it right back to that original function as well. Okay. Okay, you can tell it to give you questions that are just sine, questions that are just cosine, or flip back and forth between both. And for day 1, which we're doing right now of graphing, you don't want a phase shift on, but eventually we can add in the phase shift so you can come back to this activity when we start making it harder, and you can do that as well. Okay, so I'll leave it on sine for now. I'm going to click place point. I'm going to look at my function, and the other thing that I would encourage you to do is to have a piece of paper and to do things like write out, well, A is 2 and D is -3. So the 0 line is y equals -3, and the amplitude is 2, and then you're going to do the max and the min and all that stuff. Like, you could still do this on paper. If you think you can do some of it in your head, that's fine, but you might want to be writing that out just on scrap paper. Okay, and then what I'm going to do, as I said, the 0 line was -3 because my d value is -3, and sine starts on the 0 line, so I'm going to place a point at -3. Okay, then from there I go over 3 squares and I go up to the maximum. Well, my amplitude is 2, so from there going up to 1, 2 is a maximum of -1. Over 3 squares, back to the 0 line, over 3 squares down to the minimum. So 1, 2, because that's my amplitude, over 3 squares back to the 0 line. Okay, and so if I had written all that out and I had calculated the max and the min, I would have calculated them there. I'm counting 3 squares over. Again, as I said before, you have your 0 line, and I go up the amplitude, which is 2, to get to the max, and I go down the amplitude, which is 2, to get to the min. Okay, there's always 1, 2, 3 squares between points for now, because that's how our scale is defined. Okay, so that should be my points. What do I do now to check? I click this box, check, click it again, check, and there you have it. It goes through all of them very nicely. If you also aren't, if you get it wrong or you want to see something else, you can click this. That just helps you to place where the 0 line is. So actually what I could have done is I could turn this on and use it as a guide and say, well, my 0 line is -3. So when I'm placing my points, I start on the 0 line, max back to the 0 line, min back to the 0 line. Okay, so that'll help you graph. It doesn't show you what the actual 0 line is. You've got to move it around. But what I can do as well is I can place the points, and I can see that my 5 points are exactly right, because that is going to show you the points that the graph is supposed to be, right? Okay, I'm going to turn both of those off, and I'm going to clear my points, and I'm going to do this one more time with the same one, but I'm going to make a mistake. So my first one I'm going to put is going to go here. I'm going to count 3 squares over to the max. But what if I then only go 2 squares over and I go to the 0 line, and then 1, 2, 3 to the min, and then 1, 2, 3 back to the 0 line. Now you'll notice I didn't end at 360, and if my period is 360, that's where I should have ended, but maybe I didn't notice that. And when I check, I can see that my first point was right, but my second point missed because it should have been 3 squares over to there. And again, I can see that my points were wrong. These ones were correct. And that's what I was saying before about how it always needs to be 3 squares between each of them. I can't do 3 squares, then do 2 squares. That doesn't make any sense. Okay. The other common mistake that people might make, let me turn all of this off again, is they go here and they go to a max of -1 back to the 0 line, and then maybe they just do a minimum of 1, sorry, a minimum of -4, and then back to the 0 line. Okay, but that's wrong as well. This should be down here. And finally, again, because it's always got to be an equal distance from the 0 line to the top and a 0 line to the bottom. And this 0 line didn't go as far down. So you would never have, let me turn this off. You would never have a graph that goes like that. Not for us. It's possible to have a graph like that, but not for us, where I have a big distance here and a smaller distance there. Okay, that won't happen for the kinds of graphs that we do. Okay, so after you've done and you're happy, let's see if I can move that point. Okay, I can, and I've checked it and I'm happy with it. I'll click new, and it'll give me a new graph with a new A value and a new D value, and I can get as many of those as I want. And this is great, sort of almost infinite practice. None of the numbers are going to be too big or too crazy. A whole bunch of practice, and you can always check your answer to make sure that it's correct. So I think this is really, really good practice. I would spend more time doing this and nailing it. And then you want to be able to draw them nicely and practice a bit on paper, because it is a little bit harder to do on paper in a way, right? Using your hands instead of just clicking on a computer. But once you know the properties and know where the points are supposed to go, that's the hardest thing. That's the most important thing with all of this. So that's what this applet can help you with. This activity will really help you nail where those points are supposed to be, the max, the min, the 0 line, all that stuff. And then the paper stuff is maybe just practicing doing it with a pencil kind of thing. Okay, good luck.